We're starting a new section today about how we can organize your code better with concepts within Python's OOP implementations and also the support for classes. So in Python, because of the extensive support for object-oriented programming, very often you encounter class or class-like objects. So classes are a dime a dozen. Class-like objects are anything that's mutable, defined by the Python language, like lists and dictionaries. So we're going to take a look at 5 quick tips that we can use to improve our day-to-day Python programming and make our code more robust. The 5 things are, number 1, copying and cloning objects the right way. So how do we make sure that when we copy something, we actually have a fresh copy that we can modify without any concern, rather than a shallow copy that actually just references the original. Number 2, I'm going to talk about named tuples, which is a less used but very useful construct within Python that allows you to create almost like mini classes. We then go on to talk about creating smart values with static methods and properties. And then we talk about how we can compare 2 different objects. And finally, we wrap this up by showing you how we can do real OOP by implementing abstract base classes in Python. So this video is about focusing on copying and cloning objects the right way. So why is this a concern? So Python is very smart, right? It's so smart that it tries to save memory and time and computes whenever possible. A side effect of this is whenever you're copying things over or you're assigning objects into a new name, what it's doing, it's not actually copying all the values within that object over. All it's doing is creating a new variable and then assigning references to the thing you assigned it to. So the side effect of this is sometimes you would, let's say, have an original object, you create a new variable called copy, and then you assign it to equal to the original, thinking that you've copied everything, all the data, all the state from the original into the copy. But then once you modify the copy, you find that the original is also modified. So how do we get around this? So this is what this tip and trick is about. Let's go ahead and take a look. So we're back in our Jupyter notebook. The effects I'm talking about shows up whenever we have a nested list. So if we have original equals to a nested list like this, and then let's say we do copied equals original, right? And then we append something to copy, and then we see what copy looks like, right? So if we just copy things like this and we append 5, 6, actually I've appended twice because I've ran it before, but the idea is if we create a copy, which here is then assigned to the value of the original, firstly, if we append 5, 6 to copy, we can see that it has appended correctly. But then if we look at the original, it has also appended. So you can see that we have actually not made a copy at all, but we've just created a new name for whatever the original is. So the first way to tackle this is what we call shallow copy, which is when we do shallow copy equals to list original, right? And so let's see what original is and what shallow copy is. So original looks like this, and shallow copy looks like that. And then let's take a look at what shallow copy does. So shallow copy allows us to append things without altering the first level of our original. So you can see that the original kept its original 4 elements, which are lists, and shallow copy has been successfully appended. But then shallow copy only affects one level of any object, right? So if we change something in shallow copy, then notice that because we're changing something deeper than one level, the original is also changed. So it hasn't changed the top level, but it's changed the second level, right? So what we need to do is actually address this problem. What we need to do is import copy and use the deep copy function. Copy.deep copy Oh, actually, I don't want to deep copied list. Copy.deep copy. There we go. So, and we can inspect this. So deep copy list looks like this, and then original looks like that. Now let's do the experiment again. So deep copy list dot append 7, 8, and then we look at deep copy list. So we've successfully appended there, and let's see whether original was affected. No, it's not. And then deep copy list, we change again a second level item, A, B, C, right? We want to see whether deep copy list has changed. So we've successfully changed the first item of the first list. And before, if we have shallowed copied this would have changed original. So now let's see whether we've changed original with the deep copied list. So we've successfully actually copied something over, and not just copied references or shallow copies of the original object. So that's what deep copy and copying gives you the ability for you. So that was it. So that's very simple. The idea being, because Python optimizes a lot of how it's using memory and how it uses references, sometimes when you're assigning new variables using old values, you're not copying at all, you're simply creating a new reference. If you use shallow copying by instantiating it through a new operator, so for example, if you use the list class to instantiate a new list, but then you feed it a list that you want to copy, it creates a shallow copy, but it doesn't affect anything that's below one level deep. So what we need to do is use the copy module to use deep copy, which then allows us to clone objects the right way.